So I want to define a class. So there's the class keyword and the name of the class, and then a column. And then again, we have the indentation to indicate that we are inside the class now. So here I'm just going to define two attributes, that is name, initially empty string, and email, that is also initially empty string. Okay, so that's the class, a simple class definition. Yes.
You have to have default value.
Yeah, when you define it like this, yes. There are other ways to define it to avoid this. Yeah. We're going to talk about it in a bit. All right. So now I want to instantiate it. So I want to create a object. All right. So first I I prepare a variable that would be the reference to that object. So let's say inf1. Okay, and then equal, and then in Java we would say new employee like this, right? In Python, so this is the constructor. Now in Python we don't need the new keyword, just the name of just the constructor as a function. Okay, now I can print inf1 dot, I can read or write the attributes using the dot operator. Okay, so let's say this is John. I'm going to go with Alice and Bob so that I remember the names. And then imp1 dot email equal Alice at gmail.com. Okay, so that's one object that I refer to with the variable imp1. I can define another variable imp2 that I use to refer to another object. Now I can say imp2 dot name equal, let's say Bob, and imp2 dot email, let's say Bob at gmail.com. Okay, now how does it know? So let me try to print here imp1 dot name and imp1 dot email, and then similarly I will print imp2 as well. Okay, so when we print it, there you go. So this is what we expected, right? Now the question is, how did it know? We have a variable called name, right? How did it know that this variable name should be equal to Bob and this variable name should be equal to Alice? How did that happen? So see, when we say if1 equal employee, what happens? 3 steps. I think we talked about it before. So remind me. First step is a variable that is prepared to point to something, like in Python. It's prepared to point to something. So we call this endpoint. Second step, so when we say M1 equal new, not new, equal employee. Okay, so first step, M1, this is a variable prepared to point at something. Right? Second step, so this is one. Second step is to create the object that is based on the class employee. Based on the class employee, there's a variable called name inside this object that is initially equal empty string. And then there is another variable called email that is also initially called initially have empty string. Right? And then there is the assignment. So this is a variable at location 1, 2, 3. So the assignment part is like this. Now when we say 2 equal also employee. So again, the same 3 steps with another variable called M2, and then here's the employee. Initially, the name is also same initial value, and email same initial value. So let's say this is a 4, 5, 6, and then there's the assignment that makes it point. Okay. Now, when we say M1 dot, you see this dot operator dot name equal Alice. So what is happening here? First of all, we start by M1. So where is M1? Here. Where is it pointing at? This location. So the name we talked about here is this name. So this is the value that will change. Okay? Now if I say M2 the name equals Bob, now how does it know that the variable name is this one, not this one? Because of the address that we have here. So M2 starts here, pointing back to that object. So this is the name that we talk about here, and this is the name that will change to Bob. Okay. Now, generally speaking, when we say we have a class and we have objects of that type, we should expect them to be similar. So we should expect them to have the same value. So when we, same attributes and same behavior. So when we print them like this, it should be consistent with each other. So that the consistency is enforced in fully object-oriented languages. But it's not enforced in partially object-oriented languages like Python. So how is that? So when we say emp1.salary, for example, now salary was not defined as part of the class, but it does an object that I added randomly like this. Okay, so if I try to print emp1.salary, now someone, when you are working in a scene, and someone sees a line like this, but it didn't really look into the definition of the class, they may expect that all employees have salary, so emp2 should have salary too. Okay, and that's what would be the case in a fully object-oriented language. But here, it allowed us to print, so I'm just going to stop right before printing the second line. So for the first line, it took that assignment and it added that salary to emp1 and printed it with no problems. So that even causes more confusion. Okay, you see there was a salary there and it prints with no problems. But when you try to do the same with emp2, it will tell you, you know what? I have no idea what a salary is. It doesn't exist. Okay, if you look internally, we still, the program is still running. You see, we're still in the debug mode. If you look internally, we know the class definition has just name and email, but if you look at emp1, you will see that there is name and email and salary. And if you look at emp2, you will see that there is name and email only. Okay, so that's one source of confusion that can be avoided if we avoid defining the class variables like this. Okay, now we'll see a better way to define a class in a bit. All right, we can also delete a property. Now, if we are deleting, so del for delete, if we are deleting a property that was initialized in the class, if you're deleting the email that has an initial value in the class, it will go back to that initial value. But if you try to delete the salary, it will remove it altogether from the object. Yes. To take it what, as a string? Well, there's no way to enforce it. There is the recommendation that you shouldn't access properties like this. We should define methods to access properties, and even that not enforceable. So you have to be clever. Yes.
Benefit of using delete instead of just overwriting it, just,
It's bad. It's very bad, but it exists.
sorry?
It's very bad. It's very confusing, but it exists. It is possible. I mean, the delete, we cannot remove the delete keyword from the language, but it causes a lot of confusion. I mean, the option is there. Some people might choose to use it. Okay, so you have to be aware of its existence and its effect. But it's not a best practice. It's not a good practice. Okay, so when you see that the delete, you have to figure out whether it's deleting, removing it altogether, or isn't it going back to initial value. So if there is an initial value, go back to it. If there is no initial value, it removes it altogether. Okay. Now, I don't recommend to use the word delete. I am very, very enthusiastic about object-oriented, and I hope that they eventually enforce the principles. But what is happening right now, it's not completely enforced. So we have to work with it as it is. Okay. Now, I'll tell you so many much more worse things in a bit. But you still need to be aware of them, because even if you don't choose to do what is not recommended, other people might, and you have to deal with it. Okay. So now we need a better way. So as I mentioned, so this would remove the. We'll go back to the initial value. If I try to delete, if I use the DL with a salary, it would remove it altogether from the object. Okay, so even the keyword itself has different behavior in different situations. Okay,